Welcome to the video on multiplying and dividing rational expressions. To multiply fractions, all you need to do is multiply the numerators and multiply the denominators. You do not need to have a common denominator when you are multiplying or dividing fractions. So you can multiply any fractions you want. For example, look at number 1. 2/5 times 3/7. Let's multiply those numerators. So 2 times 3 is 6. Multiply the denominator. 5 times 7 is 35. So we get 6 over 35. Now before you multiply, you may want to think about simplifying. In this case, there is no simplifying to be done, so there shouldn't be any simplifying to do in our answer. Now on number 2, again, let's look to see if we can simplify anything. I don't think we have anything here to simplify. So we're simply going to multiply across. So we have 2x squared over 3y. Excellent. Let's try some harder examples. How about this? Now we have some simplifying we can do. Remember that you're multiplying the x minus 3 and the 3x. But a fraction really is a division problem. So here this little line is telling us that we're going to be dividing by 2x. Isn't multiplying by this x and dividing by this x just going to undo each other? Of course it is. So I'm going to simplify this before I ever multiply by canceling out those x's, since multiplying by x and dividing by x undoes each other. Will anything else undo each other? Multiplying by 3 and dividing by 2? No, that doesn't cancel each other out. How about x minus 3 divided by x plus 1? No, that doesn't cancel out. So I think we've done our simplifying. It's time to multiply. We would get 3 times x minus 3. And notice how I wrote that. Normally when we multiply, this is called a binomial, by a number. We like to put that number in front. It reminds us to distribute to everything inside that set of parentheses. And down here we'd have 2 times x plus 1. You can leave your answer this way, or you could distribute the 3 like I said, distribute the 2. However, there is another part to our answer that we actually have to put, and that's called a restriction. Okay? A restriction means that we have to make a little note that's part of our answer that says what x is not allowed to equal. Now notice we didn't solve an equation here. We were just multiplying two fractions. But if you look back to the original fraction here, remember there was an x right under there? Since there is an x in the denominator, that would mean that if we let x equal 0, right, 2 times 0 would be 0. Oh, that's not allowed. We are not allowed to have a 0 in the denominator. I'm going to make a little note of that here. X is not allowed to be 0. And the reason that I have to write that down is because notice that x is gone, right? This x is gone and doesn't show up in our answer. So I never would have known that if I had just looked at the answer here. Also note that x is not allowed to equal -1. Look right here in this denominator. If x was -1, -1 plus 1 is 0. But I don't need to write that down because that is still part of my answer. If you did write it down, that x can't equal -1, you wouldn't be wrong. It's just that it's already here. It's obvious. So I'm going to say that all of this is part of my work. Let me just make a little note here to remind you what I mean by restrictions. Make sure to write down any values that x is not allowed to equal if you eliminated it from the denominator. Right, so notice that x was in the denominator, it was eliminated. I had to make a little note of it. Let's look over here. Is there anything we could simplify first? Maybe it doesn't appear to be. Like over here we had this x and this x. We don't have that here. But notice that we could factor this denominator and we could factor this denominator as well. When you are multiplying fractions, eventually you're going to have to simplify your answer anyway. We might as well do it before we do the multiplication. That way we'll have an easier job of multiplying. So I'm going to rewrite this. We have x minus 3, and I'm going to factor that denominator, so I'm going to factor out a 2. So 2 times x plus 1. And then on this side over here, this fraction, we're going to have a 3x. And this denominator I can factor out 3, so 3 times x minus 3. So there's our new problem. Ah, look at this. I think we have a lot of stuff we could cancel now. I will even change colors. We have a 3 and a 3 here, right? This says times 3, this says divide by 3, that cancels. We also have an x minus 3 being divided by this x minus 3. Now, even though, and I didn't talk about this up here, but even though they are not in the same fraction, if we were to multiply them, they would become part of the same fraction, which is why I can simplify these right now. X minus 3 divided by x minus 3 is 1, right? That's just going to cancel. So I am left with an x in the numerator and a 2 times x plus 1 in the denominator. I guess we could redistribute that too if we wanted to. There's no need. But don't forget about this part. We need those restrictions. So is there anything that we crossed out that was in the denominator? This 3 got crossed out, but 3 isn't a variable. 3 can't equal 0. I don't need to write anything about that. But we did cross out an x minus 3. So what would make x minus 3 equal to 0 if x was 3? I make a little note to myself here that x is not allowed to equal 3. And I am all done. Let's try some dividing. When you are dividing fractions, you really want to change it into a multiplication problem. So notice this becomes 2 fractions being multiplied, and it may look like it's the same thing, but look what happened to the second fraction here. Right? The one that you're dividing by, which is this one, the second one, I'm going to actually multiply by its reciprocal. And now it's just the same as the multiplication problems that we were doing. So let's try these. So in example 5, let's change that where we are going to keep the first fraction, change the division to multiplication, and flip that second fraction. I call it keep, change, flip. Keep it the same, change this to multiplication, and flip that to the reciprocal. To multiply those, we're going to just multiply across the top, so we get 5. Multiply those denominators, we get 12. Done. Don't need to worry about any restrictions. There were no variables in this problem. All right, how about some with variables then? So for our last example, let's do our keep, change, flip. Let me write that up here. Keep, change, flip. Right, that's how I got this. I take a division problem, I turn it into a multiplication problem. Let's see if I can simplify anything. These y's I could do something with. And this can be factored, so I think we should factor that. Let's rewrite this. We have x plus 5 over 3y times y squared over, let's factor out a 2 here, 2 times x plus 5. All right. Change colors for my canceling. It's easier for you guys to see. All right. We have a y squared up here and a y. That's really just a y times a y. So if I have, let me rewrite that as y times y. Multiplying by one of these y's would be undone with this division by a y. So I'll cancel one of those. And look at this. X plus 5 divided by x plus 5. That's just going to get you 1, so those can cross out. And I think we are done there because all we have left on the top is a y. And then on the bottom, we have a 3 times 2, which is 6. But now here come the restrictions. Notice we crossed out a y. That means y can't equal 0. We also crossed out an x plus 5. So x, if that was negative 5, this would equal 0. So that's not allowed to happen either. X can't equal negative 5. And that's our whole answer. Now look at our answer here, just to make a little note. Notice that y is in our answer, but x isn't. Some people might say, well, then I guess this doesn't matter. I'm going to write it anyway, just in case, for some reason, it did matter. And that is that. It is time for you to try some practice on your own. Remember, we have the rules on our note page here for the multiplying and dividing. So each one of those problems should have something written down. Even if you're not 100% sure of it, take a guess. Good luck.